Hello everyone. In this video, let us look into the concept of zero padding and understand about zero padding by implementing it in MATLAB. Let us consider a discrete time sinusoidal signal. As we can see in the figure, the n value ranges from -30 to +29. That is, it consists of 60 intervals. X is the sinusoidal signal of the form cos 2 pi fn. Omega ranges from 0 to pi with an interval of 0.01. Note that instead of plot, we use the stem function. The plot function plots the values of x in the continuous way and the stem function does it in a discrete form. So the plot of the signal would be like this. As we can see, the y-axis consists of the cosine values and the x-axis consists of the n values. Now, let us perform the discrete time Fourier transform and visualize how the signal would become. So this is the code for the DTFT of the original signal x. As we can see inside the for loop, the y is nothing but sigma x e power minus j omega n. And note that DTFT is a continuous plot, hence we use the plot function and not the stem function. So the DTFT signal would be like this. The y-axis consists of the magnitude and the x-axis consists of the values of omega from 0 to pi. Now let us perform the DFT for this DTFT signal. So we take, since the original signal consists of only 60 samples, now we take 60 samples for this DFT also. This is the code for the DFT. Here FFT is a command which stands for fast Fourier transform and which performs the DFT of the given signal. And note that DFT is a discrete plot, hence we use the stem function. So the DFT plot would look like this. When we try to plot the DFT signal continuously instead of discrete, that is, instead of using stem, if we use plot, then we get the function like this. As we can see, we lose a lot of side lobe information when compared to the DTFT signal. This is not preferred as we lose much information. So hence, to gain the side lobes also, we need to increase the sampling rate of the original signal. The sampling rate of the original signal is predetermined and cannot be changed in between the process. And it is not, and we even can't predict the values in between the two samples. That is, it can be either high or it can be either low. So instead of that, we increase the number of samples of the original signals by adding the value 0 at the end of the signal. This is called as zero padding. That is, at the end of the signal we add the values of 0. So the following code pads zeros at the end of the original signal and performs the DFT of it. Here we use 512 samples instead of 60 samples. That is, the value till +29 is of the cos value, and from +30 to 512 it is only 0. The values are only 0. So the new plot would be like this. So as we can see, we have not lost a lot of side lobe information at all. So hence, this way, zero padding can help us to achieve the smoothness in the frequency domain. Thank you.